Hello everyone, and welcome to today's live stream slash mini tutorial on how to get random points on moving faces, regardless of topology, and this also does not rely on a rest position attribute. So, in this little setup I have right here, I have some recursive subdivision happening at the moment to make faces move along in this interesting way. And then I have a grass simulation, or kind of grass card simulation, that is affected by velocity, and basically where the points move, the grass follows and waves as you would expect. With these points, they're distributed on the recursive faces, and then the grass happens after the fact. So one of the most difficult parts with this was figuring out how to get the random points on the faces and making it work well and make the pattern not obvious, if that makes sense. So the grass simulation, also, it's fairly complex, but I've gone over this in a previous live stream, which I would recommend you watch. I forget the name of it though. My apologies. But the main thing is I want to showcase the random points on faces, because that is something that I've seen a lot of people want to make. So with all that out of the way, the problem is that the distribute points on faces node, the one that comes by default in Blender, gives you a good result. It works very well, but the problem is you can't have the topology moving. So if this scales up, the amount of points goes up or down, and it's not consistent, which is very unfortunate. Now, the solution that I have is decent. It'll work in most cases, but it's not as versatile as the default node, because for one reason that we'll get into later, the way that Blender triangulates, I don't really have access to at the moment, so there will be times where if triangulation is a big issue, of quads and n-gons and such, you may get situations where the points travel like this, where they're in a straight line rather than forming to the triangles, because I haven't quite figured that part out yet, but I should. Another caveat is that attributes don't propagate, not all of them, but you could make it so that most of them do. But yeah, let's get started on making the alternative. And also, another thing that makes this system work pretty well is that you can determine the amount of points, which is very useful if you're spawning in different effects. So, with this, let's just get started. So, the theory behind this is that we rely on the face corners. We get the location of one face corner, and then we offset that we get one face corner's position, but we also get the next one in line, and then we randomly distribute the points along that line. So we have a bunch of random points on each edge line, if that makes sense. I think it does. And then the other part is that we mix it between the current position, the random one right there, and the face's center, which is fairly simple to do. So with that, and you also want the mixing to be the square root of a random value, a different random value, and then it should give you the result that we have right here. So it should look fairly random, a very nice and deterministic point count, and it should work pretty well. Apologies for the 3-minute long explanation before actually getting into it, but here we go. So first thing that we need to do is get a random face corner position. Oh, actually, first we want the index of the first face corner. So let's use a sample index node. And let's just get the position first. But for the random face corner that we want, you need to find out the domain size to figure out how many face corners there are. And to get a random one within the face corner count, we want a random value node with this set to the max. So if we do this, it will give us a random face corner index that will not go above the actual face corner counts. So with this, we just want to get the position inputs. The position input, not the points. Blender search is a little bit weird. But if we do this, we should see that we now get points going on every single face corner. But there is a little error that we will see right here, which I kind of forgot about, but that can be easily fixed by adding or subtracting 1 by the face corner counts. That's just because the count here is like 1, 2, 3, 4, 5, while indices start at 0. So to do this, I think we just need to subtract 1. There we go. So now we have our random face corner. Let's go and put this right over here. So let's label this random face corner ID. There we go. And I forgot to capitalize that one right there, but it should be good. So now that we have that random face corner ID, we now have that position. But now is the fun/annoying part where we need to access the next corner in the face. So to do that, we need to, and I'm remembering how to do this. 1 second, everyone. Let's see. Well, I could just refer to the version I already have. But I think what we need to do is offset the corner in face by 1. So if I were to do this and then switch this out with that, we will see absolutely no difference, but we can see it's bugged out. Okay, so I will refer to the setup that I already have. 1 second, everyone. This is the downside of doing this as a live stream. Okay, so we have that, yada yada. Okay, I forgot about that. Okay, let's go back. So, with the way indices work, they're a little bit funky. So, to get the offset face corner index, we need to copy this. Let's go and have some reroutes so that this is a little better to work with. Let's set this to be an integer. So, now we want to do that offset corner in face. Offset corner in face. So, we just want that to be 1. So, now we have that next index. I know this isn't too straightforward, but it's what we have to do. So now, if we go and make it so that this uses that face corner index, apologies that this is complicated, but this is important for quite a few effects. So now let's use a mix node, a vector mix node, to see if it actually works. It should. So here we can see, yep, it is working. Very nice. So now let's make this mixture a random value. And we can see, wow, we're getting random points on said faces, and they're just working. It just works, in the famous words of Todd Howard. So now that we have that, we now have to go and make it so that they move to the center of their face by a random value that's then square rooted. So let's see, 7 minutes, not too bad time. Should have done it a little bit faster though. So if I remember this correctly, let me just double check the setup that I have here. Okay. So what we need to do is we need to do another one of these sample indices 1. So we need to copy this, but instead of getting the offset corner in face, we want to get the face of corner. So that will then give us the face index. And I should probably label this. This will be face index, face of corner. Yeah, face of corner. There we go. And now we should be able to, if we get another sample index node and switch this to be a vector once again, we should, and this is getting very messy, I apologize for that, but once again, it's what we have to do. So if we do this, well, actually no, let's break that out of there. We should get the face position. So now that we have that, we can then mix that with this, and we should see, wow, that is actually working. Very nice. And then we want to mix this with that, but we can see that this is not giving us the pattern that we want. One thing that we need to do is offset the seed value, so that it's not the same as this seed value, so that we don't get any obvious patterns. And then what we want to do is use a square root, a math square root. There we go. Then we put this into here, and we want to invert these inputs so that it actually works at the way we want. So now we should see that this works as intended. So let me increase the point count if I could. There it is. I keep forgetting that I put that last. So now we should see that the random points are pretty random, and no matter where they're moved, they are rather consistent. The only part where it becomes not so consistent is when there are the triangulation issues. But most of the time that shouldn't be a problem. But yeah, and also if you're wondering why we are square rooting this, if we don't do that, we should see that they're a bit centered towards the center. Now, this still probably isn't the best way of doing this. There's still a few little quirks, but for most scenarios, it should be fine. If your model is triangulated, it should be completely fine most of the time, as we can see here. You just move it around and they will stick on the faces very well. So, with that setup, again, it's not the most elegant, but it does work, which is good. Alright, so let's go and do this, put into some frames, and then just make it look a little bit better, so that's a bit more understandable. Let's go and do that, maybe do a bit of this. Oh shoot. The amount of spaghetti is going up, which is not great. So let's go and try to clean it up just a little bit. Yeah, and then this right here, let's go and branch this part off. Oop, that almost broke everything. No, it did break something, but for some reason undo is not functioning the way I want it to. Did that break it? Yes, it did. Oh, but that looks pretty cool. I just need to flip these values. Then we should be good. Okay. So that's how you do it. If you have any questions, please let me know in the live stream chat. But that should be working as intended. So this will be face position. Yep. So I do wish that this was a built-in mode to the distribute points on faces node, because it has just some benefits. That one, again, you can have a deterministic amount of points on said faces, and also the position of those will not change when the geometry moves or scales. The distribute points on faces node makes it so that there's an even distribution no matter if the face is big or small, which again, this is kind of a limitation. Well, I wouldn't say it's a limitation because it's kind of planned to do this, but the distribution of points will be even across every single face. Every single face will have the same or a similar amount, again, it's random, of points, but that distribution works as intended. So that is how it's done. Alright, let me just make sure that the labeling is okay. And also, one thing that I should know, you should, with the, let's see, in this node group, I made it so that you could also sample the normal from the faces, because that is something that the distribute points on faces node has, and that's pretty useful. For that, we can just use the face of corner, or face index, let's see. I'll just label this face index because it'll be a bit less confusing. So instead of getting the face position, we could just get the face normal, and that will work as intended. So that's how you would get the normal of said face. And another good point about the setup is that it is very fast. If I go and put in, let me make sure I don't put in too many zeros, 1,000,000 points. We can see that it takes, let's look at the timing, it takes 13 milliseconds. And I think the reason that it is lagging, why is it lagging? It's only 13 milliseconds. It's lagging because of something else. Oh, wait. Is it trying to run the cache? It looks like it's trying to, so maybe that's what's causing it to lag. But now it's not anymore. But it can deal with millions of points, or 1,000,000 points, relatively okay. Again, this should be, I think it's lagging because of the rendering, potentially? No. I'm actually not too sure why that's happening. Anyway. But yeah, that's how that functions. So 13 milliseconds for 1,000,000 points. Another thing that I would like to add in the future is getting the tangents. But then again, we kind of, well, you could get the face tangent, which is very useful for various effects. Yeah, that should work. But also you could just sample the UV tangents using the face. Yeah, no, should be fine. But yeah, there are more things I would like to add to this, but I just wanted to showcase how this was done, because a lot of people have been wondering how to do this, and it's very frustrating to figure out. Let me label this face corner positions. There we go. Let me turn off the timing so that we can see everything. And this is just the points. So yes, I do plan on making this a node group. I'm not sure if I'm going to share it because it still needs a bit of cooking to make sure, like, if there's a better option. Again, the triangulation is the biggest issue with this, because that's not how the models usually work, which is unfortunate. But this is the fastest method that I found, and so on. Okay. Let's see. Oh, the topic about the menu switch node, I see that happening in the chat. I think that's handled. But yes, the random points on faces. But yeah, these move along with the recursive subdivision, which I'll just show the node group for this. I did a little bit of updating. This is on Gumroad for free, but I think this was made in like 3.4 or 3.6, I forget which. So in this file, I updated it to use the repeat zone. Let me just zoom in so that you can see all the parts. It needs more updating because my gut is telling me there's a much easier way of doing this. I do have some funky controls to offset the phase between one side and the other so that you can get kind of something that looks more like a triangle, as we can see here. Which, oh, that looks so much cooler. Why didn't I render it like that? Dang it. But so that you can get stuff like that. Let me go and Control-Z that. But there's definitely a better way of doing this. I just do not have the brain power. I don't have the brain power at the moment to update it. But yeah, that is that. So let me go and re-enable the grass simulation. And that should look pretty cool. Actually, no, let's add in 10 times the amount of grass, which actually, I think it's lagging because of the alpha layers, which it always does. But that looks a little bit cooler. And also, this method should work on N-GONs. I will try to demonstrate this here. So if we get this, they won't go over to there because there's no face corners, which I did. That's very good. I forgot that I added that. But here we can see that the amount... Oh, wait a second. That's something that I forgot about. Even though... Yeah, no, that's completely fine. There will be more points with faces with higher amounts of face corners. Which, again, I didn't really intend, but I think that's perfectly fine. Here we can see the triangulation is doing kind of its job, but, you know, it's recommended to triangulate the faces beforehand. But it does work with N-GONs and quads and such. It shouldn't be too big of an issue unless your points need to be, like, right on the face. But, like, that's one thing that I've been battling with back and forth. Because in Blender, it always triangulates the faces. Because, again, that's how meshes are. They're always triangles. But the triangulation happens kind of live. So here, it goes over to this way, and then this way goes over that way. But it's not always consistent. So sometimes we can see it snap. Like this. We can see it's over there, and then it snaps to over there. As far as I know, I don't have access to that data, like the triangulated version of the faces, which would be really useful. Again, I don't think it's in the mesh topology nodes. And I'm not sure if I can make that happen, because it relies on the... It doesn't rely on the indices, I don't think. But that's a story for another time. Yep. But there we go. That is that. Again, it's a complicated setup for something that should be built in to Blender by default, but this is how you would do it. You make it into a node group so that you never have to look at it again. So there we go. 20 minutes, not bad time, I guess. But yeah, yeah, the grass sim, I'll just go and show the nodes right here if you want to replicate it. Again, it's funny that I have the grass sim, which is the flashy part of this effect, but then I just hone in on the little side part. But it is important. It's one of the foundational building blocks that, again, should be in the distribute points on faces node by default, because if you have a character that's moving, one of the most annoying things that people have mentioned is that, hey, it's not consistent, which is very unfortunate. So we make our own. And then also, I should mention, if you use the face sample index, you could output that from the node group and then just use that wherever you want. Just sample whatever you want on the face, which in this case, I'm sampling the random value which was made by the recursive subdivision GeoNodes stuff, which works pretty well. It's not like the info that you can get will only be per face or per face corner, whichever one you choose, just because it'll only be the attributes that you choose, and they won't be properly interpolated because, again, geometry nodes can't do that yet. At least, not automatically. That's stuff that only the code can do for the time being. But yeah, that is that. So I'll wrap up the stream here, a short one, but I really, really needed to get this out there because, again, it's very important, and I don't want people to be frustrated with trying to do this. Because I've had different methods of doing this in the past. One of them required the triangulation node for the aforementioned issues. But that slowed down everything by a significant degree, and it was very annoying to work with. So having a mode that is generally correct, like 90% of the time it's accurate, is good enough for me. It's only when the mesh kind of breaks, but then again, that's just how meshes work in Blender. It's good enough. Okay. Alright, just checking the chat real quick, and then we'll be ending the stream. Number of points per face could depend on the area of the polygon. Yeah, I thought about that, but the unfortunate part about that is that that would change if the model is deforming. The point of this one is so that if the faces deform, again, like we can see here, it will just work and you don't have to worry about points jumping or appearing. For that, you would just use the distribute points on faces node, because the way that that one works, if I'm correct, it's been a while since I've looked at it, it creates a ton of points in the kind of bounding box of a face and then deletes all of the points that are too far? No, it's a little bit different than that, but it's been a while since I've looked at the math behind it. And that might be a completely different algorithm that I was looking at. But that's how you would do it if you want to. But yeah, thank you all for watching, and I will see you next time. Have a good one.